in part 3, what we're looking at is just tides. Okay, why do we want to look at tides? Well, because Newton figured out that the tides were caused by gravitational forces from the moon. And other people, of course, have suspected this because the tides rise an hour later, which is pretty with the moon. And so anyway, so they suspected it, but Newton was able to figure out how it worked because he figured out the rules of gravitational forces. Anyway, so what goes on with a tide? There is what's called a tidal bulge. And that's because as the moon pulls on the Earth, then it pulls on opposite sides of the Earth with different amounts of forces. So differences in the pull or the forces. The idea is that when you are close, so let's pretend this is like the Earth and the sun or something. Anyway, when you're close, one side is closer than the other side of our planet Earth or anything, any moon, they can experience what are called tidal forces because the force on one side is different than the force on the other side. So there's a difference of forces, delta F, in that case. Now, if the object is further away, there's still a difference of forces, but now it's a smaller difference of forces. So anyway, the moon is 250,000 miles away from the Earth. The sun is 93 million miles away. So the moon is the one that's mostly responsible for the tides because it is closer. Okay, so what's going on? So our planet is being pulled by the moon, and the different layers of the planet are being pulled with different amounts. So the ocean layer is pulled away kind of from the Earth layer on one side, and then on the other side, the Earth layer is being pulled greater than the ocean layer. So what you have is a difference of forces between all these different layers, and so what happens is that you get they get stretched out, and the water forms a tidal bulge. And our planet is also stretched out a bit so that our planet is fatter around the center. It's called oblate. So our planet bulges towards the moon. Okay, so what happens is as the Earth rotates, the bulge kind of stays in place, even though there are times when there's not much water towards that direction, so when we have a large landmass. But otherwise, what you've got is this bulge trying to remain in place and the Earth rotating. And so what happens is that as you live on different places, different coasts, then you'll experience these high tides or low tides as you rotate around. So if we were looking at this from the top, so here would be the North Pole, for instance, and our Earth around it. And there would be the tidal bulge. Okay, and so what would happen is that the Earth would be rotating like this. And so what would happen is as you go around, if you lived somewhere on a coastline, you would experience a high tide. And then you would go down to where the water is lower. So that's the North Pole. So we're looking down here. So then you would experience a low tide. Then as you kept going around, you would experience another high tide. And finally, another low tide. Okay, so every day, it's quite common for someone on a coastline to experience 2 high tides and 2 low tides every day. Now, you don't always have the same amount of high tide or low tides, so you can have variations in that. So your low tide might be 2 feet above the sea bottom, Your high tide might be 6 feet above, and then your next low tide might be 3 feet above, and your next high tide is 8 feet above. So it's not always the same because the Earth tilts and the orbit of the moon tilts. So the Earth tilts at 23.5 degrees to the sun, and then the moon has a 5-degree angle. So what happens is that you get combinations of where you're going to end up in the bulge. So you can see here's a person experiencing a high tide here that looks like about 4 feet, but over here their high tide is about 6 feet. Okay, and so you can have different amounts of high tide and low tide. Not all high tides are the same height. And not all places experience the same extremes of tides. The Bay of Fundy in Nova Scotia is known for its 40-foot tides. The bay shelves upwards quite steeply, and what happens is a lot of water rushes in because it's also sort of scoops up the water as it sort of moves along. And so a lot of water funnels into the bay. And so what you get are these extreme of tides. And so there are places where the tide will be at low tide 40 feet different than high tide every day. And so anyway, here you can see this dock here, how these ships are on the ground. The water seems to be way out into the bay there. So you're not, so if you wanted to take your ship out, you need to know what time the right tide is, right? So you want to be able to maybe walk onto your ship. So you need it to be up at your dock. You need to be able to sail out of this marina. And so anyway, yeah, so very extremes of tides here. And another thing is that the water moves really fast because to fill up that 40 feet of water means that the water comes in very, very fast. And so sometimes people get trapped because they go out on the mud flats to search for clams or something, and then the water starts to come in very, very fast. And people can even drown that way. Okay, but it does offer some interesting possibilities for putting tidal energy machines out there. Because you have these extremely fast tides, that would be good for making energy. So yes, there are tidal generators that can generate electricity from high tides and low tides. Now, another thing about tides is that sometimes the sun does help out. The sun is further away, 93 million miles, so further away than the moon, but it can help out. So when you have the moon and the sun lined up, then they work together and make the tidal bulge bigger. And so that occurs when you have a full moon or when you have a new moon. And in those cases, even though the full moon is opposite, that doesn't matter. It's like pulling on someone's sweater and stretching it out, and two people pulling on the sweaters and stretching them out, still going to get stretched out. So the bulge is still bigger with the help of the sun. And so because of that, these are called the spring tides, not because they occur in spring, but because they spring forth. They're faster, stronger, higher tides. And that's where you get your highest high tides and you get your lowest low tides. So your high tides are more extreme, bigger. Your low tides are shallower. Okay, high tides, low tides. Now, the other thing that can happen, though, is sometimes the sun and the moon don't help each other out. They're perpendicular, they're forces. So in this case, you have the force of the moon in one direction and the force of the sun in a different direction. What that does is it kind of evens out the tides around the Earth. And those are called neap tides. They occur when there's a quarter moon. Okay, so you see half the moon shaded, right? The quarter moons because they're a quarter of the way through the cycle. And that is when, because the water's lowered out, your high tides are not low, so you get your lowest high tides, you get your highest low tides. Okay, so the water level might be, low tide is 4 feet, high tide is 4.5 feet. Not much difference between them. Okay, that's the end of this section.